During the Cold War, the race to build hardened underground facilities was as much about survival as secrecy. Nations poured resources into bunkers, missile silos, and command centers, convinced that steel and reinforced concrete alone would protect them from attack. But engineers quickly discovered a hidden enemy that could undermine even the strongest wall's moisture. Without proper control, condensation would corrode electronics, weaken structural components, and make underground living quarters unbearable. Entire facilities that were intended to survive decades could fail in just a few years if water and humidity were not managed correctly. The solution wasn't obvious, and it wasn't glamorous. It came in the form of advanced moisture barriers, lead-lined membranes, and capillary breaks, engineering marvels that quietly protected these installations from destruction. What you're about to learn is not only the story of Cold War ingenuity, but also practical techniques you can adapt today for underground shelters, off-grid builds, and preservation projects. Understanding why vapor barriers became a cornerstone of Cold War survival. In sealed underground spaces, moisture isn't always obvious. Water vapor can penetrate concrete, seep through joints, and condense on cold surfaces where electronics and metal infrastructure are concentrated. This microscopic threat can corrode wiring, short circuits, and even compromise life support systems. Engineers of the era quickly realized that preventing vapor infiltration was as critical as blast resistance. Early solutions included asphalt-coated sheets, but these were replaced by multi-layer polymer membranes capable of forming a continuous seal over floors and walls. The principle is simple but powerful. Prevent vapor from entering the structure at all. For modern applications, you can replicate this by installing continuous polyethylene or EPDM membranes beneath floors and behind walls in underground or partially buried structures, sealing all seams with tape or heat welding to create a continuous barrier that stops vapor at the source. Exploring the role of lead-lined membranes in high-risk areas. Lead wasn't chosen at random. Beyond its well-known radiation-shielding properties, it is completely impermeable to moisture and remains stable for decades. Cold War engineers applied thin lead sheets between flexible membranes to protect rooms housing sensitive electronics or control systems. These membranes were heat-sealed or mechanically fastened to create a continuous envelope, preventing both moisture and vapor from reaching critical equipment. This design ensured that instruments remained operational even in extreme underground humidity or after prolonged exposure to groundwater. For modern builders, the concept can be adapted using heavy-duty, waterproof membranes in place of lead, layered behind equipment or shelving to prevent moisture damage. The key takeaway is the importance of continuity and integrity. Every seam must be sealed, every surface covered, to replicate the protective effect that kept Cold War bunkers functional for decades. Learning how capillary breaks stopped water from creeping into critical areas was honestly a game-changer. You see, moisture doesn't only enter as liquid. Capillary action allows groundwater to travel upward through soil and into concrete. Engineers recognized that even a well-drained site could see moisture rise over time, potentially compromising floors, walls, and equipment. The solution was to create capillary breaks beneath slabs and around foundations. Layers of coarse gravel, drainage mats and membranes prevented water from climbing into structures. In Soviet missile silos and American command bunkers alike, these breaks were combined with vapor barriers to provide a dual defense. Water couldn't rise and vapor couldn't penetrate. For anyone building a storm shelter, root cellar, or underground workshop today, the lesson is clear. A gravel layer beneath the slab, combined with a waterproof membrane above it, provides a robust capillary break, stopping moisture before it becomes a threat and maintaining structural and operational integrity over time. Understanding how layered moisture systems protected long-term investments is, well, pretty fascinating. The genius of Cold War moisture control was in its layering. Vapor barriers stopped airborne moisture, lead-lined membranes shielded sensitive rooms, and capillary breaks prevented groundwater intrusion. Each system addressed a different aspect of water infiltration, and together they created an almost fail-proof defense. This layered approach is why many Cold War facilities remain intact today, despite decades of neglect. The strategy can be applied at a smaller scale. For an underground off-grid bunker, start with a gravel capillary break, layer a continuous vapor membrane across floors and walls, and install targeted heavy-duty membranes around sensitive equipment or storage areas. This approach ensures longevity, reduces maintenance, and protects both people and infrastructure. Seeing how these principles can be applied in modern projects is honestly quite inspiring. While we may never face the exact threats of a Cold War nuclear bunker, moisture remains a universal enemy for underground construction. By studying the engineers who mastered vapor barriers, lead membranes, and capillary breaks, modern builders can protect basements, shelters, wine cellars, and off-grid installations. Simple steps, placing a coarse gravel layer beneath slabs, sealing floors and walls with high-quality vapor membranes, and layering additional protection around sensitive areas, can replicate decades of moisture resistance. The Cold War lessons are clear. Anticipate how water moves, block it in multiple ways, and never compromise on continuous coverage. Doing so transforms a simple underground structure into a durable, long-lasting facility. If this deep dive into Cold War engineering inspired you, make sure to subscribe to Relic Logic and share this video with anyone fascinated by forgotten technologies and practical history. The secrets buried in these underground facilities aren't just relics. They're lessons you can use today to build smarter, safer, and longer-lasting structures.